Good morning, buddies. In the previous lecture, we have discussed about the leftmost derivative, rightmost derivative, and the past G. So, simply on the given grammar, we can derive the leftmost derivative for a particular string as well as rightmost derivative, and we can also construct a past G for the given string. Now, today we will discuss about the ambiguous grammar. So simply we will start with the definition of the ambiguous grammar. Then we will discuss how can we eliminate the ambiguity. So just you can say if there exists a string W that belongs to the language of the grammar such that W has two or more different past, or W has two or more leftmost derivative, or W has two or more rightmost derivative, then we can say that particular grammar G is ambiguous. So simply to prove that or to check that whether the given grammar is ambiguous or not, just we have to design two leftmost derivative or two rightmost derivative or two different past G. Simple. So then we can declare that particular grammar will be ambiguous. So let's start with a real life example. Suppose any grammar is given to you and whose productions are suppose S2, S plus S, and S asterisk S, A and B. So this is simple, the production rule defined for a grammar G. Now the string is given to you, that is A plus A asterisk B. So simply for that particular string, if you derive two leftmost derivative, then you can declare that given grammar will be the ambiguous grammar. Or if we construct two different past for the same string, then we can also declare that this is the past. So there are this is the ambiguous grammar. So this is the various way. The means there are three ways by which you can declare that the grammar is ambiguous or not. So first one is leftmost derivative through the leftmost derivative. Second one through the rightmost derivative, and through the construction of past. So let's start with this particular example. So in this example, just we will try to find the leftmost derivative, means for this particular string, right? So your production rule is given in this format. So just start with the production rule S to S plus S. So I'm here going to derive first leftmost derivative, that is LMD1, right? So just we are going to start from the start symbol by taking the production S to S plus S. Now we are going to derive the leftmost derivative. So here you can see that there are two variables, S and S. So in that case, we have to opt the leftmost. So leftmost will be the S. So now we have to expand this leftmost derivative on in all the steps, because we are here deriving the leftmost derivative. So now just see here, just in place of S, we can write A, B, S, asterisk S, or S plus S. So now we have to see, or we have to check our required string, whether we have to require here A or B, because A and B both are the terminals that can be provided through start symbol, that is S. So here you can see that we have to require A in the leftmost side. So now just check whether this variable can produce you A. Yes, it can produce. So just replace this S by A, because this production is defined in the grammar. So in this case, just see here, this is only the single variable. So just we can expand this variable by S asterisk S, because we have to require asterisk also. So now again we have two variables, so we have to expand left one. Is it clear? Because we are again I am telling you that we are going to create the leftmost derivative. That's why we are again and again expanding leftmost derivative. So in this case, just S is replaced by A. So now you can find the string A plus A asterisk capital S, where S is what? it is again a variable. So now you required b here. So can we replace this s by b? Yes, it is given the production rule. So now finally we will replace this s by b. So finally we can find a leftmost derivative for the string a plus a asterisk b. Now we will try to find another leftmost derivative for the same string. If it exists, then we can say that the given grammar will be ambiguous grammar. So now just see the another leftmost derivative. It is noted that we are now we are finding next leftmost derivative, that is leftmost derivative 2. So just we will start with the start symbol, similar as the previous one, that is s. Now you can expand this s by s plus s or s asterisk s, because these are two productions given in the grammar. So simply here I want to replace this s by s asterisk s. So this is s asterisk s, right? Now this is left variable and this is the right variable, right? So since we are trying to obtain the leftmost derivative, so we should expand left one. So in place of this one, you can see here in this s can be expanded as s plus s. So in place of this s, I'm just putting s plus s. Clear? Now you can find here there are three variables, that is s and s, right? So just we have to expand the leftmost, that is this one. So that's why I have changed the color of this variable so that you can understand easily. So just s is replaced by s because it is the given production. So you can find here the leftmost terminal of the string. And again you have two variables, s cross s. So simply this is the left one. Again we expand it by a. So this the outcome string is a plus a asterisk s. And finally you required b. So s just you should check whether s can be replaced by b. So this is production that is given to you. So now s can be replaced by b. So finally you can find the same string by using the next leftmost derivative, or by leftmost derivative 2. That means for the given string, you have two or more than two leftmost derivatives. So we can declare that the given grammar is ambiguous. So this is simple way to declare or to check whether the grammar is ambiguous or not. Now we can try by the another method, that is by constructing the pass tree. So simple, we can construct a pass tree for a plus a asterisk b by using these given production rule. And now we can find the yield or the string by concatenating from left to right all the leaves, right? If we concatenate all the leaf node from left to right, suppose in this situation a plus a asterisk b, you can find the string. Simple. This string can be called as the yield of the tree, yield of the pass tree. So sorry, simply this is the one pass tree that will produce you sorry, a plus a asterisk b. Now just we are going to try for the another pass tree. So this is another pass tree that can be constructed for the same string. So now you can check whether the outcome string is same or not. So simple, on the same way, just start with the leftmost leaf node and cover all the all the nodes by concatenating all the levels a plus a asterisk b. So in both the cases or from both the pass tree, you will get the same string. That means the same string for the same string you have more than one pass tree also. So we can check, we can declare simply that the given grammar is ambiguous, right? So now let's start with one more example. So in this case, suppose a grammar is given to you, that is G is given as S to S, B, S and A. Now you have to prove whether this grammar is ambiguous or not. But one important point here that I want to discuss with you, that there are two types of problem. First one is a string grammar along with the string given to you, and you have to you have to prove by calculating, by designing two different pass tree, or by obtaining two different leftmost derivative for that string, right? Another type of question can be asked you, that is simple, a grammar is given to you. In this situation, you have to assume, or you have to consider a string by own, right? Because string is not given to you, so you have to you have to assume a string by own. Then you have to derive two different pass tree for that string, right? And or you can derive two leftmost derivative or two rightmost derivative for that string, similar to the previous one. But the difference is only that the string is not given to you. So in this situation, I just consider the string w equals to a b a b b b b. But it should be noted that the assume string must belongs to this grammar, right? So you can derive two pass tree for that string. Let's start with this. So just SBS and A is given to you. So just we are going to start with S to SBS. S is SBS, right? Now this we required here A. So S can be replaced, S can be terminated with A. So just we will write here A. This is again a terminal, so no problem at all. We also received this B. Now again S is can be replaced with SBS. So in place of S we can replace A. B is already here, and S is replaced by SBS because it is the given production SBS, right? So finally, if we concatenate from left all the leaf node from left to right, then we can find the string, and that string is the same as the consider string. Is it clear? So simply it is the pass tree for the string. Now just we are going to design another pass tree, right? So in this case, simply just because there is only one production rule to expand this S, so just we have to start with S to SBS. But here in place of S, I written A, means S is terminated by A. But here we have to design another pass tree or different pass tree. So here just we are trying to expand this S by SBS again. So simply this S is replaced by SBS, and this S is replaced by A. So after concatenate all the leaf nodes from left to right, we can find the string. So finally, the outcome string will be the same as the consider string, right? So that means for the same string or the consider string, we have two different pass tree. That means we can say the given grammar is ambiguous. So we can prove this question that the given grammar is ambiguous. So simply now question can be asked by having the four parts. Simply a grammar is given to you, a string is given to you. Now the first part will be to find the leftmost derivative for the string, and second part will be find the rightmost derivative, and third part will be to design or construct the pass tree or derivation tree, and the fourth part will be is this grammar is ambiguous. So in fourth part you have to write the answer in yes or no. Then you have to write the statement by so that you can prove this whether yes or no. So if yes, if you written yes, it means you have to show the two different derivative tree, or two different pass tree, or two different leftmost derivative, or two different rightmost derivative for the string. If you write no, in this case you can explain your answer that there is only single pass tree or a leftmost derivative is possible for the same string. So the given grammar is not ambiguous. So this is about the ambiguous of
Thank you.
grammar.